Dynamic panel data model. So this is the last topic for your semester 4 coursework for panel. After completing this, we go through the another part of your syllabus, as I have already mentioned, relating to the principal component analysis and factor analysis. Only these two parts we will cover among the multivariate analysis in your advanced econometric theory 2. So what about dynamic panel data? Dynamic model, as you know, if we consider lag dependent variable as a possible regressor, then the model becomes dynamic. So till now, you have considered autoregressive structure of a single variable in the framework of univariate model in testing for unit roots. So they are basically the dynamic model. Because if you look at the structure of the model, AR1, for example, so YIT is equal to phi I YIT minus 1 plus UIT. This is the basic structure of AR1. So here we are using lag dependent variable as a possible regressor. So when lag dependent variable is used as a regressor, we have a dynamic model. So when dynamic behavior introduced in panel structure, we have dynamic panel data model. Okay, so in the case of univariate model, we are using the lag dependent variable. But in the case of a multiple linear regression model, when we are using some explanatory variables, exogenous variables, X, so in that case, the model becomes complicated, because in that case, the possibilities for dynamism may appear from two sources. One, from the dependent variable YT minus 1, again, from the independent variable xt minus 1, xt minus 2, etc. So we try to look at the structure of the model when we introduce lag dependent variable as a possible regressors, and what kind of typical problem we have to face when we try to estimate the model. Okay, so when you are using lag dependent variable as a possible regressors, your model becomes autoregressive. And in autoregressive structure, you need to test whether unit root presents in the series or not. Particularly in the case of a dependent variable you are using in your model. Okay, so if unit root presents, you cannot estimate the model by using the conventional method, by using OLS, or by using our fixed effect or random effect kind of model. So in that case, we have to take care of the variable cautiously, and we have to follow the appropriate methods. And as in the case of a time series, you can say, if a series contains unit root, you can apply the variable in OLS after removing the unit root process. So after removing unit root behavior, we can use the variable in OLS estimates. So the same principle could be applicable in the case of panel data as well. In other words, suppose you are testing unit roots for different series individually. Y, the dependent variables you are using in your model. Also x1, x2, x3, etc., the independent variables you are using in your model. So you have to carry out the unit root test. And if unit root presents, then you have to take either first difference or second difference, or after taking appropriate difference, you have to convert the non-stationary series into a stationary one. After that, you can use them in estimating a model. Okay, but if unit root presents, as we have discussed in the case of a time series, we can use the unit root series in estimating a relationship between them if they are co-integrated. Okay, so similar kind of analysis we can carry out in panel data model as well. And we have the resulting models known as the panel co-integration. So panel co-integration is the extension of the co-integration we have used in a single time series. So here the possibility is we discuss the model first by assuming that the variables we are using are stationary. So there is no problem of unit root. This is our underlying assumptions. And if the variables are stationary, in that case, what kind of method we need to follow? After that, we introduce the possibility of unit root. And if unit root presents, what kind of method we should follow in estimating a model? Okay, so first, let us start with the case where we assume that the variables are stationary. Under these assumptions, we try to structure and discuss the basic problem of estimations in dynamic panel framework. Okay, so this is the basic task for discussion today. Dynamic panel data model, as I have already mentioned, when lagged values of the variables, particularly the dependent variables, are used in a model, you have a dynamic model. Okay. But in some cases, the lagged values for other covariates you can also consider. So to understand the basic structure of the dynamic model, we can consider this kind of linear form of the model. Please write it down. YIT is equal to phi naught plus sum of phi j YIT minus j plus x prime IT beta plus UIT. So in this specification, as shown in this presentation in equation 1, we are considering YIT, the dependent variable, follows ARP process, autoregressive of order P. So when P is equal to 1, you have AR1 process. So this is the generalized framework of a dynamic model. YIT is equal to phi naught plus sum of phi j YIT minus j plus x prime IT beta plus UIT. Now here x prime IT includes all covariates, including the lagged values as well. Okay. And UIT, the random error, is decomposed by following the conventional rule. If we are considering one-way error component, so UIT is equal to mu I plus epsilon IT. Mu I, all of you know, the cross-section specific heterogeneity. Epsilon IT is the, as usual, random error with zero mean constant variance. Okay. So if we substitute the decomposed part of the original error UIT, your model ultimately becomes YIT plus YIT is equal to phi naught plus phi j YIT minus j plus x prime IT beta plus mu I plus epsilon IT. So this is the basic structure we try to analyze today. Now this kind of model, by incorporating the lag dependent variable and the lagged values of the covariates, are very much popular and most useful in the macroeconomic modeling. If you want to look at some macro structure, the more appropriate model should be the dynamic panel model. Also, if you look into the labor market analysis in macro sense, not in micro sense, in development economics in general, this kind of dynamic panel data model may be more appropriate instead of the static panel data model we have discussed earlier. Okay, so as the dynamic form of the panel data econometrics is more appropriate in analyzing the macroeconomic behavior, we have to consider, we have to analyze the basic structure of the model and what kind of typical problem you have to face with the incorporation of the lag dependent variables into the structure. Okay. Now, first of all, try to understand the utility of introduction of the lag dependent variable. In this specification, we have used ARP process of Y. So what does it mean? What would be the implication of this model? This model simply says that current value of Y in cross-section unit I. So if you consider Y denotes GDP. So GDP of country I in period T depends on the GDP of the past years as well as some determining factors of GDP. If you go through the macroeconomic model, you know GDP depends on rate of interest. GDP depends on other macro variables. So if you incorporate here within X other than GDP as the explanatory factors for GDP, and these explanatory factors may be contemporaneous as well as maybe the past values. So when we introduce the lagged values, so basically we are incorporating the entire history of the process of generating GDP, for example. So the presence of lag dependent variable as a regressor, particularly we are focusing on the lag dependent variable because the basic problem in a dynamic model or the basic advantage of a dynamic model is to analyze the behavior of the past values of it along with the other variables affecting y. Okay, so when you are using the lagged values of y, you are incorporating the entire history in determining y. So you are considering, you are trying to explain yit in terms of the past values of yit, along with other explanatory variables included in x. Okay, so the basic implication of a dynamic model is we can analyze the entire history of the dependent variable and any impact of xit on yit under the condition that we have incorporated into the historical behavior of the variable. Therefore, the dynamic panel data model captures simultaneously the long-run equilibrium relationship along with the short-term dynamics. So this is the basic advantage of a dynamic model, and if we apply the dynamic behavior in a panel structure, you can easily understand the basic advantage of this kind of model to explain some macroeconomic behavior we have in a theory. Okay, বোঝা গেল এই পর্যন্ত?
Yes, sir.
So this is our basic structure.
Sir,
বলো।
স্যার বলছি এখানে যখন আমরা ল্যাগ ডিপেন্ডেন্ট মানে ল্যাগ ভ্যালুগুলোকেও যখন ইনকর্পোরেট করছি, তার মানে তো আমার মানে ওটার থেকেও একটা এন্ডোজেনিটি প্রবলেম আসছে, প্লাস আমার এক্সাইটি যে ফ্যাক্টরটা ওটার থেকেও আসছে।
হ্যাঁ, সেটা তো বটেই, সেটা সেই জায়গাতেই তো আমরা আসবো আলটিমেটলি। এন্ডোজেনিটি ফ্যাক্টর আসছে বলেই তো আমাদের স্পেশাল অ্যাটেনশন নিতে হবে এখানে। ওকে, সো as you have mentioned, the lag dependent variable as a possible regressor creates a possibility of non-zero correlation between regressor and the random error. And this non-zero correlation between regressors and the random error, you know, is a problem of endogeneity. So when we are using lag dependent variable as a possible regressors to incorporate the dynamics, we have to face additional problem, what is known as the problem of endogeneity. The similar problem you need to face in carrying out unit root test as well, because if you look at the basic model to be estimated in carrying out unit root, it is a dynamic model because you are taking either AR1 or AR2, whatever may be, all are the dynamic model because you are using the lag dependent variables as a possible regressors. So in carrying out unit root test, you also have to face a problem of endogeneity, but we have not discussed this problem at this stage because the main focus was how to carry out unit root test, not to estimate the model. Okay, but in a dynamic panel, our basic focus is on estimation. That's why we are pointing out the problem of endogeneity, but you have to keep in mind same problem you have to take into account in carrying out unit root test. Clear? So as there is a possibility of endogeneity problem, if you apply OLS, your estimated coefficients will be biased as well as inconsistent. So this is the basic problem in any dynamic model if you try to estimate by using OLS. So if you apply OLS, your estimated results will be biased as well as inconsistent. Okay. So how this kind of inconsistency or biasness appears in a dynamic model? To understand the issue, let us consider first the univariate model. So just look at this model. And you can remember, we are using this model in carrying out unit root test. When we are discussing the problem of unit root in panel framework, we used yit is equal to phi naught plus phi 1 yit minus 1 plus uit as the basic model that to be estimated. Okay. So in that case also, you have to face the similar problem. Now, let me look at how this kind of problem appears and how to resolve this problem. So in a dynamic model, in general, the basic problem of estimation relates to the problem of endogeneity that appears because of the incorporation of the lag dependent variable as a possible regressor. So when you are trying to estimate a dynamic panel data model, your problem will be different dimensional. First, you have to take care of cross-sectional heterogeneity, as we are discussed in a static panel data model. Mu I, the presence of mu I into your model. How to take care of it. Second, how to take care of the problem of endogeneity. So in a dynamic panel data model, you have to solve the two problems simultaneously. One is the possibility of heterogeneity, which is also unobserved. Second, the possibility of endogeneity. Okay. Now, how to take care of the possibility of heterogeneity? The problem is similar as we discussed in the case of a static panel data model. So you can consider the problem by estimating a model either in terms of fixed effect or random effect. Because if you use fixed effect, you can avoid the problem of presence of mu I in your model. Also, in the case of a random effect, you can use mu I as a part of the random error. So you can tackle the problem of unobserved heterogeneity as in the case of a static panel data model. But what additional problem you have to face when you use lag dependent variable is the problem of endogeneity. So we are focusing mainly on the problem of endogeneity here, how this kind of problem appears and how to resolve this problem. Okay, so let us start with the basic univariate model in panel data framework. This is AR1, yit is equal to phi naught plus phi 1 yit minus 1 plus uit. So if you consider one-way error component, substitute the value for uit as mu I plus epsilon it. So this is the one-way error component model by taking only one variable y. So this is a univariate model for one-way error component. And I have already mentioned, we assume that the series or the variable you are using is stationary. And you know the stationarity restriction, the coefficient for AR1 should be less than 1. So we assume throughout the discussion, initially, the value for phi 1 less than 1. Later on, we relax this assumption we introduce the cases where y follows unit root, that is phi1 is equal to 1. And as we are considering a panel, we have different possibilities here, and we have already discussed in the section of unit root, panel unit root. So this is the extension of this generalized, this kind of model that will be discussed later on. Okay, so for time being, suppose the variables is stationary, that is, we assume that phi1 less than 1. So under this assumption, and along with this assumption, stationarity assumption, we also consider our classical assumptions on the random error, that is expected value of epsilon it equal to 0, and the variance of the random error is constant, covariances are 0. That is, we are considering that the error is homoscedastic following non-autocorrelation behavior. Okay. Next assumption for time being, suppose the expected value for epsilon it given yit minus 1 equal to 0. So this assumption is needed to get consistent estimator in OLS, unbiased estimator in OLS. But if this assumption is violated, then the problem of endogeneity appears. Okay. And also we assume that expected value of mu I given yit minus 1 not equal to 0. That means cross-section heterogeneity presents in your model. So regarding epsilon it, we can say the errors epsilon it are identically independently distributed across the cross-section units I over time t with no serial correlation. So we can write the distribution of epsilon it symbolically in this way: epsilon it distributed IID with 0 mean, constant variance, sigma square epsilon. Okay. Now, to estimate this model, if you follow the random effect kind of behavior, we need another assumption. That is, we need the distributional assumptions of mu I, and you can understand the utility of this assumption if you try to remember the random effect model we have discussed in a static framework. When we are considering random effect, we can take mu I as a part of the error. So we have to consider the composite error in estimating the model. And we have shown earlier, when we are considering the composite error, the possibility of non-autocorrelation presents, and to resolve this issue, we have to follow the GLS, generalized least square. So OLS will not be applicable in the case of a random effect model, because all classical assumptions are not fulfilled in the case of a random effect model, although we assume this kind of assumptions. Okay. Now, first of all, try to follow the steps as we have used in the case of a time series data. So consider equation 3. What is equation 3? Please write down. Yit is equal to phi naught plus phi 1 yit minus 1 plus mu I plus epsilon it. That is equation 3. We have equation 5 we have shown earlier. So this is, in this equation, put the value of t is equal to 1, 2, 3, etc. sequentially. So if you put the value t is equal to 1, what would be the result? yi1 is equal to phi naught plus phi 1 into yi naught, because you have put t is equal to 1, plus mu I plus epsilon I1. Okay. Next, put the value of t is equal to 2, yi2. yi2 is equal to phi naught plus phi 1 yi1 plus mu I plus epsilon I2. Have you followed my point?
Yes. Yes, sir.
Yes, sir.
Now in the second expression, yi2 in the left hand side, in the right hand side, you have phi naught plus phi 1 yi1. So substitute the value for yi1 from the previous step and rearrange the term. yi1 এর ভ্যালুটা বসিয়ে দাও, দিয়ে টার্মগুলোকে রিঅ্যারেঞ্জ করো। And tell me the result. Final expression for yi2. yi2 সমান কি পাওয়া গেল বলো আমাকে। পেয়েছো রেজাল্ট?
Yes, sir.
Tell me.
So 1 plus phi 1 bracket phi naught plus phi 1 square yi naught plus bracket এর মধ্যে 1 plus phi 1
প্রথমটা কি? phi naught into 1 plus
1
phi
plus
1,
phi 1
হ্যাঁ, plus
plus phi 1 square yi naught, তারপরে প্লাস mu I into 1 plus phi 1
হ্যাঁ,
plus phi 1 epsilon I1 plus epsilon I2.
সবার মিলেছে?
Yes, sir.
সবার ক্ষেত্রে একই এসেছে?
Yes, sir. Yes, sir.
Okay.
Yes,
So then find out yi3. So yi3 will be equal to phi naught plus phi 1 yi2 plus mu I plus epsilon I3. And substitute the value for yi2 from the previous step. Tell me the result after simplifying the expression. কি রেজাল্ট পেলে বলো?
স্যার বলবো?
বলো।
স্যার phi naught into 1 plus phi 1 ব্র্যাকেটের মধ্যে 1 plus phi 1 তারপরে প্লাস
দাও, দাও,
5
দাও, দাও। কি পেলে? প্রথম এক্সপ্রেশনটা কি হলো?
মানে
phi
ফার্স্ট
naught into
phi naught into থার্ড ব্র্যাকেটের মধ্যে 1 plus phi 1 into ফার্স্ট ব্র্যাকেটে 1 plus phi 1।
ওটাকেও তো সিম্পলিফাই করা যায়।
ওটা 1 plus phi 1
আচ্ছা, হ্যাঁ,
plus phi 1 square.
Yes. phi naught into 1 plus phi 1 plus phi 1 square. এইটা। তারপরেরটা কি হলো? phi 1 cube into yi naught.
Yes, sir.
তাই তো?
Yes, sir.
তারপরেরটা mu I into 1 plus phi 1 plus phi 1 square. Clear?
Yes, sir.
তারপরেরটা epsilon it দিয়ে যে এক্সপ্রেশনটা এসেছে সেটা কি?
phi 1 square epsilon I1 plus phi 1 epsilon I2 plus epsilon I3.
So if you remember, it is similar to the case what you have already got in a time series. Only additional term appears relating to mu I. So ultimately, you will get the expression like this. So if you carry on the process, YIT can be written as phi naught into 1 plus phi 1 plus phi 1 square plus up to phi 1 to the power t minus 1. Then I have written the term relating to mu I. So mu I into 1 plus phi 1 plus phi 1 square plus phi 1 to the power t minus 1 plus phi 1 to the power t yi naught plus sum of phi 1 to the power j epsilon I t minus j varies from 0 to t minus 1. Or you can write in more compact form in this way. YIT is equal to phi naught into sum of phi 1 to the power j varies from 0 to t minus 1 plus mu I into sum of phi 1 to the power j is equal to 0 to t minus 1 plus phi 1 to the power t yi naught plus sum of phi 1 to the power j epsilon I t minus j varies from 0 to t minus 1. So this is for YIT. Similarly, you can get the expression for YIT minus 1. So if you just change the value for t here place t minus 1 in place of t. So the expression becomes yit minus 1 is equal to phi naught into sum of phi 1 to the power j. J varies from 0 to t minus 2 plus mu I into sum of phi 1 to the power j. J varies from 0 to t minus 2 plus phi 1 to the power t minus 1 yi naught plus sum of phi 1 to the power j epsilon I t minus 1 minus j. Okay. Now, if we assume mod value of phi 1 less than 1, so in limiting sense, what would be the value for yit? This part will be 0. This is the homogeneous part. This is the part for homogeneous solution. This will be 0 if phi 1 less than 1. This part will be 0 as t tends to infinity. And this part becomes phi 1 to the power j epsilon I t minus j. J is equal to 0 to infinity. And you can get the sum of this part and sum of this part. If you take the sum of this series and this series as t tends to infinity. Okay. And after expressing the relation in that way, you can find out the conditional mean value for yi. Why we can, I have said here the conditional mean, because we are finding out the expected value of yit given the cross-section heterogeneity, mu I. So it will be equal to phi naught into 1 by 1 minus phi 1 plus mu I into 1 by 1 minus phi 1. Okay. And you can compare this result with our previous time series case. If you put the second part equal to 0, you can get the result for a single time series. Similarly, the variance for yit is equal to sigma square epsilon by 1 minus phi 1 square. Okay. Now in equation 5, so what we have done here, how you can look at the AR1 structure in panel framework. We can look at AR1 structure in this way. And this form is extremely helpful in finding out the mean value for yit, in finding out the variance for yit or any other moments of the dependent variable yit. Okay. Now, the question is how to estimate this model. If we try to estimate this model as shown in equation 5, epsilon it is as usual error term, mu I provides cross-section specific heterogeneity, which is unobserved. So we don't have any information about mu I. So to estimate the model just by following the static panel data case, we need to eliminate mu I. And we can eliminate mu I in different way. First way, just to follow the within estimation kind of model. So we need to follow the mean corrected form. Another way to eliminate mu I, just to take the first difference of the both sides. If you take first difference, mu I will be cancelled out. Another way to take care of the presence of mu I is to follow the least square dummy variable model. All of you know, and we have already discussed earlier. Okay. So to estimate this model, suppose we are using within estimation or mean transformation form. So this is the form we have used earlier in a fixed effect model. Difference is, in your earlier model, in the right hand side, you have xit minus x bar I dot. We have used the symbol earlier. But here, in place of x, we are using yit minus 1 as an explanatory variable. Clear? So the fixed effect within transformation form can be written in this way: yit minus y bar I is equal to phi 1 into yit minus 1 minus y bar I minus 1. What is y bar I minus 1 and y bar I? Y bar I indicates sum of yit divided by t. Y bar I minus 1 indicates the mean value by taking the 1 period lag values. Okay? লেখা হয়েছে এই অবধি ইকুয়েশন 10?
Yes, sir.
Yes, sir.
Now, as there is no mu I here, you can apply OLS. So problem of unobserved heterogeneity is resolved, as we have got in the fixed effect model. So what would be the OLS estimate of phi 1? Phi 1 hat is equal to, just apply the formula, sum of xi yi divided by sum of xi square. So by applying this formula, you will get this result. এই এক্সপ্রেশনটা বুঝতে পারলে কিনা বলো? So you can compare this part as x. So the numerator shows sum of x into y divided by sum of x square. Like this. Okay. This is the OLS estimate of equation 5. Now, if you substitute the value here for yit minus y bar I, what is the value for yit minus y bar I? You can get it from equation 10. Yit minus y bar I is equal to this one. So substitute the value for yit minus y bar y is equal to phi 1 into this plus this. এই এক্সপ্রেশনে yit minus y bar I এর বদলে এইটা বসিয়ে দাও, phi 1 into it minus 1 minus y bar I minus 1 plus epsilon it minus epsilon bar I. Then you will get this expression. এটা কি করে পাওয়া গেল বোঝা গেল?
Yes, sir.
Okay. So after getting this result, you can show that expected value of phi 1 hat will be equal to phi 1 only when the second term is 0. Expected value of the second term is 0. And this is the result in the case of a cross-section data as well as in a static panel model. But in our case, when we consider yt minus 1 as the explanatory variable, if you look at the numerator, This is the covariance component. Covariance between yt minus 1 and epsilon it. This part will be not equal to 0. In other words, yit minus 1 will be yit minus 1 minus y bar I minus 1 will be correlated with epsilon it minus epsilon bar I. Can you say why? Because if you look at the formula for epsilon hat I, in epsilon hat I, you have taken the all previous values for epsilon. So when we have taken the previous values for epsilon, they will be correlated with the previous value for y. In other words, in epsilon bar I, there is a component of epsilon it minus 1. And you know epsilon it minus 1 will be correlated with yit minus 1 by the structure of our model. বুঝতে পারলে? এই পার্টটা 0 হবে না কেন বুঝতে পারলে? After taking expectation.
স্যার একবার রিপিট করবেন?
আচ্ছা, এখানে আমরা যেটা বললাম যে this part will be not equal to 0. Why? কারণ তুমি ইকুয়েশন 5টা লক্ষ্য করো। ইকুয়েশন 5 যেটা আমাদের বেসিক মডেল ছিল, yit is equal to phi 1 yit minus 1 plus mu I plus epsilon it, তাই তো?
Yes, sir.
তাহলে ওখানে আমি কি পাচ্ছি? yit epsilon it, they are correlated. Clear? So we can say yit minus 1 epsilon it minus 1 will be correlated. ব্যাপারটা বুঝতে পারছো?
Yes, sir.
Now in this expression you have yit minus 1 here, but there is no epsilon it minus 1 apparently. But if you look at the formula for epsilon bar I, what is epsilon bar I? Epsilon bar I is equal to sum of epsilon it divided by t. So in this sum, you have taken all the previous values of epsilon. So within epsilon bar, there is a component of epsilon t minus 1, which is correlated with yt minus 1. For that reason, this second part will not be equal to 0. And because of this reason, expected value of phi 1 hat will not equal to phi 1. That is, phi 1 hat is not unbiased estimator of phi 1. Similarly, if you take the probability limit of phi 1 hat, you can say that the probability limit of phi 1 hat is not equal to phi 1 because of non-zero part of the second part. So if we apply OLS by taking yt minus 1 as a regressor, the estimated coefficient will not be unbiased as well as consistent. So this is the problem we have to face if we want to estimate a dynamic panel data model. Clear?
Yes, sir.
So how to resolve this problem? You know, one popular way to resolve endogeneity is to use the instrumental variable. So in estimating a dynamic panel data model, we can use instrumental variable estimation. And this methodology was developed first by Anderson and Xiao in 1981. So let we discuss the methodology of using instrumental variable to estimate dynamic panel data model as developed by Anderson and Xiao in 1981. Again, consider the same equation, univariate model with AR1 YIT is equal to phi naught plus phi 1 YIT minus 1 plus mu I plus epsilon IT. Now, in our earlier discussion, to eliminate mu I, we have used within estimation techniques as used in a fixed effect model. But Anderson and Xiao considered the first difference of this equation to eliminate mu I. If you take the first difference, how to get first difference? This is YIT. So you can write similarly the value for YIT minus 1. So YIT minus 1 is equal to phi naught plus phi 1 YIT minus 2 plus mu I plus epsilon IT minus 1. And take the difference. So you have YIT minus 1 in the left hand side. In the right hand side, phi naught will be cancelled out. Mu I will be cancelled out. So what you have ultimately in the right hand side? Phi 1 into YIT minus 1 minus YIT minus 2 plus epsilon IT minus epsilon IT minus 1. Or you can write in this way, delta YIT which is equal to YIT minus 1 equal to phi 1 delta YIT minus 1 plus delta epsilon IT. হয়েছে? এফডি কমপ্লিট করেছো?
Yes, sir.
সবাই লিখেছো?
Yes, sir.
Yes, sir.
Now look at the structure of equation 1. In the random error, there are two terms, epsilon IT minus 1. In the regressor, YIT minus 1, YIT minus 2. Okay. Now, by this model, you can say YIT and epsilon IT are correlated because YIT is equal to this. So you can say YIT and epsilon IT are correlated. But from this model, we cannot say YIT minus 1 and epsilon IT are correlated. এখান থেকে কি বলতে পারি YIT minus 1 and epsilon IT correlated? বলতে পারি? বলো। কারণ তুমি ধরে নিয়েছো এর আগে আমরা যে অ্যাসাম্পশন গুলো লিখেছিলাম তার মধ্যে একটা আছে দেখো এক্সপেক্টেড ভ্যালু অফ epsilon IT given YIT minus 1 equal to 0. Expected value of epsilon IT given YIT minus 1 equal to 0. This is the condition for exogenity. এটা আমরা ধরে নিয়েছি। এটা ধরে নিলেও আমার এন্ডোজেনিটি প্রবলেম চলে আসবে। কিভাবে চলে আসবে? তাহলে আমি এই ইকুয়েশন থেকে কি বলতে পারছি? YIT epsilon IT এর সাথে কোরিলেটেড, কিন্তু YIT minus 1 এর সাথে কোরিলেটেড নয়। YIT minus 1 টা কি? Y টা হচ্ছে আমার আগের পিরিয়ডের, আর epsilon IT হচ্ছে কি? epsilon এর ভ্যালুটা হচ্ছে কারেন্ট পিরিয়ডের। সো কারেন্ট পিরিয়ডের শক আগের পিরিয়ডের Y কে এফেক্ট করতে পারবে না। কাকে এফেক্ট করবে? ফিউচার Y কে এফেক্ট করবে। আমি যদি আজকে যদি কোনো একটা শক আসে আমার ইকোনমিতে, তাহলে সেই শকের ইম্প্যাক্টটা ফিউচারে ট্রান্সমিটেড হবে। পাস্টে কি ট্রান্সমিটেড হবে? হবে না। সো ইন দ্যাট লজিক উই ক্যান সে epsilon IT cannot affect YIT minus 1, but epsilon IT can affect YIT, YIT plus 1, YIT plus 2, etc. বুঝতে পারলে?
Yes, sir.
তাহলে আমার এই মডেলে YIT minus 1 এর সঙ্গে epsilon IT এর কোরিলেশন নেই, সো দেয়ার ইজ নো প্রবলেম। তাহলে আমি যদি এই মডেলটা ডাইরেক্টলি আমি এস্টিমেট করতে পারতাম তাহলে আমার কোনো সমস্যাই ছিল না। বাট উই ক্যানট এস্টিমেট দিস মডেল ডাইরেক্টলি বিকজ অফ দ্য প্রেজেন্স অফ মিউ আই। এখানে মিউ আই রয়েছে, সো উই নিড টু এলিমিনেট মিউ আই। মিউ আই কে আমি কি করে এলিমিনেট করব? আইদার বাই ইউজিং উইদিন গ্রুপ এস্টিমেশন as we have shown earlier, or by taking the first difference. তাহলে উইদিন গ্রুপ এস্টিমেশন যদি নিই তাহলেও আমার আলটিমেটলি এন্ডোজেনিটি প্রবলেম চলে আসছে এখানে। এবার যদি আমি ফার্স্ট ডিফারেন্স নিই, ফার্স্ট ডিফারেন্স নিলে আমার মিউ আইটাকে এলিমিনেট করে দিলাম, এই প্রবলেমটাকে আমি তাড়িয়ে দিলাম। কিন্তু এইটা তাড়াতে গিয়ে আমি একটা অ্যাডিশনাল প্রবলেমকে ইনভাইট করলাম। সেটা কি? সেটা হচ্ছে এন্ডোজেনিটি। কিভাবে ইনভাইট করলাম? এবার এই ইকুয়েশনটা খেয়াল করে দেখো। এখানে epsilon IT minus 1 রয়েছে, এখানে YIT minus 1 রয়েছে। দে আর কোরিলেটেড। বাট YIT minus 2 এটার সাথে কিন্তু কোরিলেশন নেই। কোরিলেশন আছে কার? YIT minus 1 এর সাথে epsilon IT minus 1 এর। যে পিরিয়ডের শক সেই পিরিয়ডের Y এর সাথে কোরিলেশন থাকবে। So in that sense, in this model, if we estimate equation 1 in place of the original specification, we have to face endogeneity problem. because here the error, we can consider this part as a whole as error and this part as a whole as the regressor. So there is a correlation between the regressor denoted by this or delta yi minus 1 and the error term this or delta epsilon it. They are correlated. Clear? তাহলে এন্ডোজেনিটি প্রবলেমটা এইভাবে ইন্ট্রোডিউসড হচ্ছে মডেলে। আমি ডাইরেক্টলি তুমি যদি লেখো এখানে এইটা আমি ডাইরেক্টলি বলতে পারবো না যে আমার রিগ্রেসরের সাথে এপসিলন রিলেটেড। রিগ্রেসরের সাথে এপসিলন রিলেটেড নয় এখানে। কেন? কারণ এপসিলন হচ্ছে আমার কারেন্ট পিরিয়ডের শক। আমি যদি আজকে একটা শক ইম্পোজ করি ইকোনমিতে তাহলে তার এফেক্টটা ফিউচারের দিকে যাবে, পাস্টের দিকে তো আসবে না। Therefore, epsilon it is not correlated with yit minus 1 logically. But in a panel data, যে কারণে আমার টাইম সিরিজে কোনো সমস্যা হয়নি। টাইম সিরিজে যখন আমরা AR1 ডিসকাস করেছিলাম, we did not discuss about endogeneity problem in times. কারণ টাইম সিরিজেও তো আমার মডেলটা এরকমই ছিল, AR1টা তো একই, এখানেও যা লিখেছি ওখানেও তাই। তফাৎটা হচ্ছে কি এখানে মিউ আই এসে গেছে, ওখানে মিউ আই ছিল না। এই মিউ আই চলে আসার জন্য আমাকে একটু সতর্ক হতে হচ্ছে। কিরকম? আমি মিউ আই এর ভ্যালুটা জানি না, আননোন, তাহলে এটাকে এস্টিমেট করতে গেলে আমাকে টেকনিক্যালি মিউ আই কে এলিমিনেট করতে হবে। টু এলিমিনেট মিউ আই উই হ্যাভ টেকেন ফার্স্ট ডিফারেন্স অন বোথ সাইডস টু গেট দিস মডেল ইন দিস ফর্ম। Now, when we converted this model into this form, then the problem of endogeneity is introduced, because here yit minus 1 is correlated with epsilon it minus 1. Past period এর shock, past period এর value কে affect করবে, খুবই স্বাভাবিক। But epsilon it minus 1 will not affect yit minus 2. কারণ yit minus 2 টা হচ্ছে আবার এই t minus 1 এর রেসপেক্টে আগের পিরিয়ডের ভ্যালু। Therefore, epsilon it minus 1 cannot affect yit minus 2, but it affects yit minus 1. So whatever may be, if we treat the expression within parenthesis, within bracket as a whole as the regressor, and this expression within bracket as an error term, we can say that error and regressors are correlated, and the problem of endogeneity will appear. To resolve this problem, we use instrumental variable. And perhaps you know what instrumental variable is. We can define instrumental variable as those variables which are not correlated with the error term, but they are related with the regressors we have. So how do you get the instrumental variable? We have to search for a new variables in such a way that it has a strong relationship with the regressor but no relationship with the error. This kind of variable is called instrumental variable. Clear? পরিষ্কার হলো জায়গাটা? কি পরিষ্কার হলো না এখনো ক্লিয়ার হয়নি?
No, sir, clear. Yes, sir. Clear.
Okay. So write this model in this form: delta yit is equal to phi 1 delta yit minus 1 plus epsilon it. Now here, substitute different values of t here, keeping I intact. So what would be the left hand side? left hand side will be a vector. Left hand side ta লেখো কি হবে delta yi1, delta yi2, delta yi3. In this way, delta yi capital T. Small t varies from 1 to capital 2 to capital T. Because after taking first difference, you have lost one variable. So better to write this by substituting t from 2, not from 1. So in the left hand side, you have delta yi2, delta yi3. In this way, delta yit, capital T. Or if you assume you know the value for y naught, what is y naught? Past value for y1. So in that case, you can put the value for t is equal to 1 to capital T. Because if you put t is equal to 1 in the left hand side, here you have got y naught. তাহলে যদি আমরা ধরে নিই y naught is given, y naught the initial value is given. So in that case, we can put delta yi1, delta yi2. In this way, delta yi capital T. This is a column vector in the left hand side. In the right hand side, for this term, you have phi1 into, again you have a column vector containing the element delta yi naught, delta yi1, delta yi2. In this way, delta yi capital T minus 1. Okay. For the third component, you have a vector delta epsilon i1, delta epsilon i2. In this way, delta epsilon it. Now this column vector you have written in the left hand side. Suppose we denote it as delta yi. Similarly, the vectors you have in the right hand side, let we denote them as delta yi minus 1. That is it is related to the past year value, 1 period lag value, plus delta epsilon I. So delta epsilon I means it is a column vector which is equal to delta epsilon I1, delta epsilon I2. In this way, delta epsilon IT. And as we have discussed, yit minus 1 is correlated to epsilon it minus 1. So we can write expected value of delta yit minus 1 into delta epsilon it not equal to 0. And the problem of endogeneity will appear. To resolve this problem of endogeneity, Anderson and Xiao recommended to use only yit minus 2 in place of these regressors. এইটার বদলে যদি আমি শুধু yit minus 2 ইউজ করি in estimation, then this new variable yit minus 2 will be correlated with this part but not correlated with this part. Therefore, yit minus 2 may be the possible instrument in this case. এই জায়গাটা বুঝতে পারলে কি? Is it clear?
স্যার এটা একবার এক্সপ্লেইন করবেন?
হ্যাঁ, তাহলে এটা প্রথমে দেখো এই 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 টোটাল পুরোটার সাথে এই পুরোটার একটা কোরিলেশন আছে, যেখান থেকে আমার এন্ডোজেনিটি প্রবলেমটা চলে আসছে। কেন কোরিলেশন? কারণ এই যে ইপসিলন it মাইনাস 1 এর সঙ্গে yit মাইনাস 1 কোরিলেটেড। এবার এই এন্ডোজেনিটি প্রবলেমকে দূর করার জন্য আমাকে একটা নতুন ভ্যারিয়েবলের কথা ভাবতে হবে, যেটা এই রিগ্রেসারের সাথে কোরিলেটেড কিন্তু এই এরারের সাথে কোরিলেটেড নয়। এবার সেই ধরনের পসিবল ভ্যারিয়েবল কি হতে পারে? ওয়ান পসিবল ভ্যারিয়েবল মে বি yit minus 2. Why? Because yit minus 2 is not correlated to the error term this, but yit minus 2 is correlated with the regressor, this part. বোঝা গেল?
ইয়েস স্যার।
কেন correlated? Because your original specification is AR1. So by AR1 structure, we can say that yit minus 1 is correlated with yit minus 2, yit minus 2 is correlated with yit minus 3, etc. So in that sense, if we consider yit minus 2, then this variable will not be correlated with the error, but will be correlated with the regressor. Therefore, we can say yit minus 2 may be one possible instrument that could be used for estimation. Another possible instrument may be here, because you are expressing your original model in first difference form. So if you want to use your instrument in first difference form, then you can take yit minus 2 minus yit minus 3 as a possible instrument, because yit minus 2 minus yit minus 3 will not be correlated with this error, but it will be correlated with this regressor. Therefore, in Anderson and Xiao model, the possible instrument may be yit minus 2 or yit minus 2 minus yit minus 3. Okay? So if you take yit minus 2 in place of the regressors you have here, so what is your regressor? Delta yi minus 1, if you consider it in a vector form. So in place of this regressor, you can use yit minus 2, that means yi minus 1 in vector form. So if we use yit minus 2 as an instrument, then we have a moment condition like this. Expected value of y prime I minus 2 into delta epsilon I equal to 0. এই কন্ডিশনটা বোঝা গেল? How to get? কারণ ইনস্ট্রুমেন্টাল ভ্যারিয়েবলের ডেফিনেশনই তাই, যেটা আমার এরারের সাথে কোরিলেশন হবে না। তাহলে yit minus 2 কে আমি ইনস্ট্রুমেন্ট বলবো তখনই যখন এটা এরারের সাথে কোরিলেটেড নয়, অথচ রিগ্রেসারের সাথে কোরিলেটেড। এবার আমার যে মডেল এখানে, যেটা আমি ইকুয়েশন 2 ফর্মে লিখেছি এইটা, বা এর এক্সপ্যান্ডেড ফর্ম হচ্ছে ইকুয়েশন 1। ইকুয়েশন 1টা দেখলে পরিষ্কার বুঝতে পারবে যে কেন yi(t-2) এরারের সাথে কোরিলেটেড নয় অথচ রিগ্রেসারের সাথে কোরিলেটেড। তাহলে আমি এখানে কি করলাম, আমার রিগ্রেসার হচ্ছে আমার এই পার্টটা পুরোটা, আমি তার বদলে আমি কি নিচ্ছি, অন্য একটা ভ্যারিয়েবল নিচ্ছি যেটা রিগ্রেসারের সাথে কোরিলেটেড হবে কিন্তু এরারের সাথে কোরিলেটেড হবে না। সেই ভ্যারিয়েবলটা কি নিলাম, সেই ভ্যারিয়েবলটা নিলাম yi(t-2), কারণ yi(t-2) এই পুরোটার সাথে কোরিলেটেড, পুরোটাকে আমি রিগ্রেসার হিসেবে ধরছি, কিন্তু yi(t-2) এটা এই এরারের সাথে কোরিলেটেড নয়। তাহলে yi(t-2) যদি এরারের সাথে কোরিলেটেড না হয়, then we can write expected value of yi(t-2) into delta epsilon it equal to 0. We have written here in vector form, that's why we have ignored the suffix t, because we have considered all possible values of t. এবার ক্লিয়ার হলো?
Yes, sir. Yes, sir.
নাকি আবার বলবো?
স্যার এখানে yi(-2) প্রাইম যেটা, সেটা তাহলে রো ভেক্টর।
হ্যাঁ, yi(-2)টা হচ্ছে কলাম ভেক্টর, তো এটা প্রাইম নিচ্ছি মানে রো ভেক্টর। প্রাইম নিলাম কেন, কারণ এটা তো আমার স্কেলার হতে হবে, আমার তো এক্সপেক্টেড ভ্যালু মানে মিন ভ্যালু তো একটা সংখ্যা, মিন ভ্যালু তো একটা ভেক্টর নয়। ভেক্টর মিনের ভেক্টর যখন নেবে তখন আলাদা, কিন্তু একটা কতগুলো ভ্যারিয়েবলে যখন তুমি মিন ভ্যালু বার করবে, সেই মিন ভ্যালুটা তো একটা নাম্বার, so it is a scalar. So for that reason we have taken y prime into delta epsilon i, এটাকে যদি মাল্টিপ্লাই করো তাহলে একটা স্কেলার কম্পোনেন্ট পাবে।
ওকে স্যার।
So it should be equal to 0. এবার এই কন্ডিশনটাকে আমরা ইউজ করব টু এস্টিমেট দ্য মডেল। এবার এটা তো আমার থিওরিটিক্যাল কন্ডিশন গেল ফর পপুলেশন। Sample counterpart expectation means mean value, so you can take the sum of y prime I minus 2 into, এবার এই ডেল্টা ইপসিলন i এর ভ্যালুটা যদি বসিয়ে দাও, সো ডেল্টা ইপসিলন i হচ্ছে আমার এরর, তাহলে এর স্যাম্পল কাউন্টারপার্টটা কি হবে, রেসিডুয়াল, কারণ তুমি যখন এস্টিমেট করবে ইউ আর ইউজিং স্যাম্পল। সো এস্টিমেশন পার্টে এই ভ্যারিয়েবলটা তো নোন হতে হবে, অবজার্ভড হতে হবে, ইপসিলন i হচ্ছে আনঅবজার্ভড, তাহলে এর অবজার্ভ কম্পোনেন্টটা কি, রেসিডুয়াল, যেটা আমি স্যাম্পল থেকে পাবো। So the sample counterpart of this condition we can write this. Sum of yi minus 2 prime into delta yi minus phi 1 hat delta yi minus 1 equal to 0. এই যে within bracket যে এক্সপ্রেশনটা আমরা পেলাম, this is basically equal to epsilon hat I, the residual. Okay, ঠিক আছে?
Yes, sir.
Yes, sir.
এবার এটাকে সেপারেট আউট করো, দুটো পার্ট রয়েছে, সো ইউ ক্যান রাইট ইন দ্য নেক্সট স্টেপ সাম অফ y স্টার I minus 2 into delta yi minus sum of y star I minus 2 into phi 1 hat into delta yi minus 1 equal to 0. এবার এই ইকুয়েশন থেকে phi 1 hat এর ভ্যালুটা সলভ করো। What would be the value for phi 1 hat? কি পেলে বলো ভ্যালুটা? phi1 hat is equal to কত এলো?
Sir, summation yi prime I minus 2 delta yi divided by summation yi prime I minus 2 delta yi minus 1.
হ্যাঁ, কিন্তু এটা তো ভেক্টর ফর্মে রয়েছে, এটা মাথায় রাখতে হবে। তাহলে যে ডিভাইডেড বাই যেটা লিখলে সেটা হয়ে যাবে অ্যাকচুয়ালি টু দি পাওয়ার -1 ইনভার্স। এইটা, এটাই তো পেয়েছো বেসিক্যালি, তাই তো?
Yes, sir.
Yes.
এবার এখানে ডেল্টা ওয়াই আই এর ভ্যালুটা যদি বসিয়ে দাও, ডেল্টা ওয়াই আই ফ্রম দিস ইকুয়েশন, এইটা যে ইকুয়েশনটা আমরা এস্টিমেট করছি সেখান থেকে ডেল্টা ওয়াই আই এর ভ্যালুটা যদি আমরা বসিয়ে দিই, দেন ইউ ক্যান গেট দিস রেজাল্ট। ভ্যালুটা বসিয়ে বার করে দেখো এটা আসছে কিনা, দেখে দেখে টুকে নেবে না, সিম্পলি কপি করবে না, ভ্যালুটা বসাও, ক্যালকুলেশন করো। এটা আসছে কিনা দেখো, হয়ে গেলে আমাকে বলবে। Have you got this result? After substitution, হয়েছে?
Sir, ওটা phi1 plus কেন আসছে?
হ্যাঁ, কোনটা?
Second, যেখানে আমরা delta yi এর ভ্যালুটা সাবস্টিটিউট করছি।
হ্যাঁ,
that means
ডেল্টা ওয়াই আই,
phi1
ডেল্টা ওয়াই আই মানে কোনটা? ডেল্টা ওয়াই আই মানে হচ্ছে এইটা তো।
equation 2, হ্যাঁ,
হ্যাঁ,
phi1 delta yi minus 1 plus epsilon i।
হ্যাঁ,
সেটা মাল্টিপ্লাই করছি sum of yi prime minus 2, yi prime minus 2 দিয়ে মাল্টিপ্লাই করলে ওটা phi1 into sum of delta yi prime minus 1 and delta yi minus 1 হবে।
কি হয়েছে? এনি কনফিউশন? প্রথম পার্ট থেকে phi1টা বেরিয়ে আসবে, রিমেনিং পার্ট যেটা পড়ে থাকবে সেটা হচ্ছে এইটা।
Yes, sir, clear.
Now, if you look at this expression, you can find the expected value of this term will be 0. because if yi prime minus 2 into delta epsilon I, expected value of this is 0. Right? So as the expected value of this part is 0, you have unbiased estimator as well as consistent estimator. And the estimated value of phi 1 hat you have got in this way is called the instrumental variable estimate, IV estimate. This is not OLS. So how to get IV estimate? Just by using this moment condition. What is the moment condition? Moment condition is the variable you are considering, which is called instrument, into the error. Expected value is 0. Okay. Now, later on, the methodology was extended by Arellano and Bond in the form of a system estimation. So in Anderson and Xiao, considered only YIT minus 2 as an instrument to estimate this model. But if you think at this stage, there may be several instruments you can consider. That is, any value of y taking from t minus 2 backwards, all are correlated to this regressor and not correlated to this error. So you can take any past value starting from t minus 2 as a regressor, or the differences value of y starting from t minus 2 as a instrument. So there are several possibilities for taking instrument. But in Anderson and Xiao model, we have taken only one instrument. For example, as we have shown you, by taking YIT minus 2 as instrument only. So instead of taking just only one instrument, if you consider all possible instruments, you have a method what is known as the system method. And you can estimation this system, that is, you are generalizing the moment condition. In Anderson Xiao model, you are applying this moment condition, only one moment condition you are applying here. And by applying a single moment condition, you have got the result, estimated value, what is called the instrumental variable estimates. Now, if we generalize the moment condition like this by taking all possible instruments, you have a method what is known as generalized method of moment, GMM. So later on, Arellano and Bond extended the methodology by Anderson and Xiao by considering all possible instruments and by using the GMM. Okay, so let me try to understand the methodology developed in Arellano and Bond to have a GMM estimation, and what would be the additional benefit in using GMM instead of a single moment condition as used in Anderson and Xiao. Okay, so what is GMM? GMM is generalizing the moment condition. You have an estimation, what is known as the GMM estimation. So how to generalize the moment condition? Again, consider the same model as used in Xiao, Anderson and Xiao, that is, first write down this model in first difference form to eliminate the mu I, cross-section specific heterogeneity. So this is your model you want to estimate. And you have estimated this model by following Anderson and Xiao, just by taking YI minus 2 as an instrument, only one instrument. Now we are extending the methodology by considering all possible instruments. How to get all possible instruments? In this expression, suppose t is equal to 2. So write down this expression for t is equal to 2. So it looks like this. So this is a specific case for t is equal to 2. yi2 minus yi1 in the left hand side is equal to, in the right hand side, I1 into yi1 minus yi0 plus epsilon I2 minus epsilon I1. Okay? Dikhecho?
Yes, sir.
So for t is equal to 2, the expression looks like this. And in this expression, can you tell what would be the instrument here? এই এক্সপ্রেশনে কোনটাকে আমি ইনস্ট্রুমেন্ট হিসেবে নিতে পারবো, ভ্যালিড ইনস্ট্রুমেন্ট হিসেবে? We can take yi0 as a valid instrument because yi0 is not correlated with the error. বুঝতে পারছো ব্যাপারটা? এই এক্সপ্রেশনে আমি yi0 কে আমি ইনস্ট্রুমেন্ট হিসেবে ধরতে পারি কারণ yi0 এই এররের সাথে কোরিলেটেড নয়, অথচ রিগ্রেশনের সাথে কোরিলেটেড। Is it clear?
Yes, sir.
So in this case, for t is equal to 2, what would be the moment condition? Moment condition will be just this. Delta epsilon I2, because here you have put t is equal to 2. So this is the error. What would be the error? Delta epsilon I2. And what is the instrument here? yi0. So expected value of delta epsilon I2 into yi0 equal to 0. তাহলে এখানে আমরা কি করলাম? একই জিনিস অ্যান্ডারসন আর সিয়াও যেটা বলেছিল, আমি সেই মোমেন্ট কন্ডিশন ইউজ করছি। এখানে যেটা করেছিলাম, এখানে যে মোমেন্ট কন্ডিশন পেয়েছিলাম, কিভাবে পেয়েছিলাম? বাই কনসিডারিং ইনস্ট্রুমেন্ট yi minus 2. So in this case, yi minus 2 and the error uncorrelated, and this is the moment condition. So we follow the same rule here also. So for t minus in the same framework, in the same set of equations, if we consider a particular case t is equal to 2, you have yi0 as the instrument, and the moment condition becomes expected value of delta epsilon I2 into yi0 equal to 0. এবার একইভাবে consider a situation where t is equal to 3. So substitute t is equal to 3 in equation 1, either in this form or in this form. Equation 1 এ t is equal to 3 বসিয়ে দাও, তাহলে কি পাবে রিলেশনটা? রিলেশনটা দাঁড়াবে yi3 minus yi2 in the left hand side. In the right hand side, you will get phi1 into yit minus 2 minus yit minus 1 plus, I'm sorry, this is yi3 minus yi2 is equal to phi1 into yi2 into yi1 plus epsilon i3 minus epsilon i2. Right?
Yes, sir.
So you will get this equation at t is equal to 3. এবার এখানে আমার পসিবল ইনস্ট্রুমেন্ট কি কি হতে পারে বলো তো?
yi1 and yi0.
হ্যাঁ, yi1 হতে পারে আর yi0 হতে পারে, কারণ yi1 yi0 দুটোই এররের সাথে নট কোরিলেটেড বাট রিগ্রেশনের সাথে কোরিলেটেড। সো ইন দিস কেস yi0 and yi1 are the valid instrument. Okay, so at t is equal to 3 you have two moment conditions, one for yi0, this one, another for yi1, this one. Similarly, write down the equation at t is equal to 4. t is equal to 4 এ কি হচ্ছে লিখে ফেলো। At t is equal to 4 you have this one, yi4 minus yi3 in the left hand side. In the right hand side, phi1 into yi3 minus yi2 plus epsilon i4 minus epsilon i3. ঠিক আছে, লিখেছো?
Yes, sir.
স্যার
Now tell me the possible instruments in this equation.
yi0, yi1, yi2.
Yes, yi0, yi1, yi2. These are the three possible instruments. So we are considering instrument in terms of the variable. You can also consider the instrument in terms of the difference of the variable. We are not considering till now. আমরা এখানে ইনস্ট্রুমেন্ট গুলোকে ভ্যারিয়েবলের টার্মসে দেখছি, yi0, yi1, yi2। তেমনি তুমি যদি ডিফারেন্স ফর্মে দেখো তাহলে প্রত্যেকটা কেসেই, যেমন এই ক্ষেত্রে তোমার ডিফারেন্স ইকুয়েশনটা হতে পারে ডেল্টা yi2 ডেল্টা yi1 and delta yi2 and delta yi1, এই দুটো হতে পারে possible instrument if we consider the difference of the variable. ঠিক আছে, তাহলে ইনস্ট্রুমেন্টটাকে আমরা দুরকম ভাবে দেখতে পারি, in terms of the variable itself or in terms of the difference of the variable. We are considering instrument in terms of the variable itself. সেখানে আমরা দেখতে পেলাম for t is equal to 4 we have three possible instruments yi0, yi1, yi2. So you have three moment conditions here. One relating to yi0, another relating to yi1, and third one relating to yi2. So for t is equal to 4, you have how many instruments? Three instruments. yi0, yi1, yi2. So if you generalize this process for t period, how many instruments you can get?
T minus 1.
T minus 1, no. Yes, t minus 1 number, yes. So the valid instruments will be yi0, yi1 up to yi t minus 2. So for t, you can get t minus 1 number of moment conditions. But in Anderson and Xiao, we have taken only one moment condition. So this is the difference. So if we consider all possible moments in estimating the model, we have a generalized method of moment. So let we restrict t is equal to 4 to understand the method properly. So for t is equal to 4, what are the possibilities? If capital T is equal to 4, total time span 4. Total time span 4 means t is equal to either 2 or 3 or 4. If you have total time period 4, total time span 4 years. So in that case, you can consider small t is equal to 2, small t is equal to 3, and small t is equal to 4. And you have 6 moment conditions in total. One for the t is equal to 2, 2 moment conditions for small t is equal to 3, 3 moment conditions for small t is equal to 4. So how many total moment conditions for capital T is equal to 4? Capital T is equal to 4 means suppose you have a 4-year data. You have information for 4 years. So in that case, you can construct 6 moment conditions. তাহলে তোমার 4 বছরের ডেটা যদি থাকে, 4 বছরের ক্ষেত্রে তোমার মোমেন্ট কন্ডিশন হচ্ছে 6 খানা। By taking all moment conditions, এই moment condition গুলোকে যদি আমরা একসাথে লিখি, suppose we write it down it in a functional form, gi of phi1. So we need to estimate phi1 by considering all moment conditions together. This is the basic framework for GMN. তাহলে gi of phi1 is equal to এই 6 খানা moment condition লিখো একটা vector form. This is the first moment, first condition for t is equal to 2, 2 moment conditions for t is equal to 3, and 3 moment conditions for t is equal to 4. So you have these 6 moment conditions. Okay. Now substitute here the value for epsilon I2, epsilon I3, etc. So you have got this vector. So how to get this vector? By taking all moment conditions together. And here you have a parameter phi1. That's why we have written gi of phi1. So this vector is a function of phi1. You have information on y. On the basis of these informations, you have to find out the value of phi1. Okay. লিখেছো? এ অবধি কমপ্লিট করেছো?
Yes, sir.
Yes, sir.
ইকুয়েশন 7 অবধি?
Yes, sir.
Now you can rewrite this same equation in this form, in matrix form. You have written in a vector format. You can write the same relation in matrix form in this way. There are 3 columns. First column relating to t is equal to 2. Second column relating to t is equal to 3. Third column relating to t is equal to 4. So in the first column, we have only one instrument, yi naught for t is equal to 2. In the second column, we have 2 instruments, yi naught, yi1 for t is equal to 2. In the third column, we have 3 instruments, yi naught, yi1, yi2 for t is equal to 4. So these instruments into delta epsilon I, delta epsilon I1, delta epsilon I2, delta epsilon I3, delta epsilon I4. So if you multiply this row into this column, this row into this column, in this way, you will get this vector. Okay? Or in compact form, you can write gi of phi1 is equal to zi prime into delta yi minus phi1 delta yi minus 1. What is z prime? Z prime is the transpose of this matrix. If you take transpose of this matrix, you will get z prime. So z is equal to this. I'm sorry. Z is equal to this. Transpose of this matrix, you have written here. Transpose of this matrix is equal to z. So what will be z? Z is equal to this. Just take the transpose. And this matrix is called the matrix for instruments. By taking all instruments, you have get this matrix, Z. And you define similarly delta yi minus 1 used in this expression. Okay. Now the moment condition in generalized form, you can write expectation of zi prime into delta epsilon I equal to 0. So we have written different steps by taking just capital T is equal to 4, assuming that you have a data for 4 years. So for any value of capital T, you can construct the instrument matrix like this. And the corresponding vectors delta yi minus 1 in this form. দেখা হয়েছে?
Yes, sir.
Now let we define S is equal to expectation of gi of phi 1 into gi prime of phi 1. So if you look at this expression, it is basically a matrix formed by gi of phi 1 and multiplied by gi prime of phi 1. So this matrix is obtained by considering all the moment components. Substitute the value for gi of phi 1. Gi of phi 1 you have written in this form, zi prime delta epsilon I. Gi of phi 1 is equal to zi prime delta epsilon I. So replace gi of phi 1 by zi prime delta epsilon I. So you will get ultimately S is equal to this. So we are assuming S is equal to this. Now, as we are using the symbol expectation, it is related to the population. So its sample counterpart becomes S hat is equal to 1 by n, capital N, number of cross section, sum of zi prime delta epsilon hat I into delta epsilon hat prime I into zi. Epsilon hat indicates the residual, the estimated value for epsilon. Now this S hat will be used in estimating phi 1 by applying GMM. So what we have taken at this stage, we have basically take the square of the moment like this. We have multiplied, and multiplication in matrix form looks like this. Now define the sample moments in this way. Gn suffix n means by taking all cross section units capital N of phi 1 is equal to sum of zi prime into the expression within bracket. It is equal to delta epsilon. Okay, so this part within bracket is basically delta epsilon. So this is nothing but the moments. Moment zi prime into epsilon, delta epsilon. If you separate it out, the first part becomes sum of zi prime into delta yi. Second part minus phi 1 into zi prime delta yi minus 1. Symbolically, let me write it in this form. Where S z delta y means sum of zi prime into delta y divided by capital N, and sz delta y minus 1 means sum of zi prime delta yi minus 1 by n. Okay. লিখেছো?
Yes, sir.
Now, how to get GMM? GMM is basically obtained by solving this minimization rule. So you have to minimize n into g prime n. What is g prime n? Gn, you have defined Gn in this way. Gn of phi 1. So g prime n phi 1 into s hat inverse. We have already defined s hat into Gn of phi 1. And substitute the value for Gn of phi 1, you will get this expression. So we have to minimize this part to find out the value of phi 1. And this value is called the GMM estimates of phi 1. Its solution. So if you minimize it with respect to phi 1, you have to set first derivative of this function with respect to phi 1 equal to 0. And after solving, you will get this result. And this estimation is known as two-step Arellano-Bond GMM estimator. Two-step Arellano-Bond GMM estimator. Why two-step? In the first step, you have to estimate S hat. In the second stage, by using this S hash, you have to estimate the value for phi 1. Okay. লিখেছো এই অবধি?
Yes, sir.
Yes, sir.
Now later on, this model was extended further by considering the system GMM estimator. What is the logic for extension? This extension was made by Blundell and Bond in 1998. The basic logic was the lag level instruments in the Arellano-Bond model. In the Arellano-Bond model, we have taken lagged values of the variables as instrument. yi0, yi1, yi2, etc. All the past lag values are considered as instrument. Okay. But the lagged values of the variables as an instrument becomes weak. Why? You can understand why we call weak, because we are considering the lag values of the variable as instrument, and by the structure of the model, the variable follows AR1 structure. So if the autoregressive process is persistent, that means the coefficient for phi 1 is nearly equal to 1. Then you have a problem. Okay. So to resolve this issue, the model is further extended by considering the lagged differences as the instrument, along with the lagged values of the variables used in Arellano-Bond. So in a system method, system GMM method, as suggested by Blundell and Bond in 1998, the number of instruments is more. So in addition to the lagged values of the variables, as we have in Arellano-Bond, yi0, yi1, yi2, etc., we also consider the lagged differences, that is delta yi0, delta yi1, delta yi2, etc. So if we consider all those instruments together, you have a method what is called the system GMM method. Okay. Now, to have an idea about the system GMM, let me extend the basic model in this way. Earlier, we have used the univariate model by taking this part. Now consider additional part beta xit. We have not used till now xit as the explanatory variables. Now introduce xit along with the lag dependent variables as the explanatory variables here. So this is the basic model in one-way error component form. Have you written?
Yes, sir.
Now to eliminate mu I, you have to take first difference. So the first difference model looks like this. After taking first difference, mu I will be cancelled out. Now consider the moment conditions. In Arellano-Bond model, you have used this unconditional moment condition by taking lagged values of the variable as an instrument. Okay. In terms of the model we have considered now, you have another variable xit. So in terms of the past values of the variable, the moment conditions used in Arellano-Bond just like this. Now what is the extension developed in Blundell and Bond? Along with this moment condition already used in Arellano-Bond, they consider another set of instruments by taking the past differences delta yi naught, delta yi1 in this way, delta yi t minus 1. The past differences are also used as the instrument, which are not used in the Arellano and Bond model. তফাৎটা বুঝতে পারছো? তাহলে আমরা যদি instrumental variable estimation থেকে শুরু করি as developed by Anderson and Xiao, তোমার বেসিক মডেলটা কি AR1, এবার AR1 in panel structure, if you consider one-way error component, then you have to eliminate mu I. To eliminate mu I, you have to take the first difference. After taking the first difference, you have a model which contains endogeneity problem. Now to resolve endogeneity problem, Anderson and Xiao suggested only one moment condition by taking only one instrument. In terms of the AR1, we have taken only one instrument yi t minus 2. Now later on, Arellano and Bond, they consider all possible moments in terms of the variable itself. And by generalizing it, you have GMM estimation. Now, in Blundell and Bond, the model have been extended further by considering the lag differences as well as the instrument. So in Blundell and Bond, you have taken all moments in terms of the variable, past values of the variables, as well as in terms of the past differences of the variable, past values. So these are the moment conditions in Arellano bond. If you consider xit as explanatory variable, the moment conditions in Arellano bond includes these two. Along with this, in Blundell and Bond, we can use the past differences as the instrument for y as well as for x. So addition in Blundell and Bond is these two conditions. So if we consider all moment conditions, both in terms of the variables as well as in terms of the past differences, you have a system GMM estimator. Okay. Now, as the number of moment conditions increases in system GMM estimator, the solution of this model developed in Blundell and Bond is more complicated as compared to the Arellano bond. Okay. Later on, this method is further developed, further extended, but for your syllabus, we have restricted our analysis by considering only 3 estimation methods in dynamic panel. One is Anderson-Xiao by considering only one instrument. Number 2, Arellano bond in GMM estimation framework by considering all instruments in terms of the past values of the variable. And the third model developed by Blundell and Bond in 1998 by considering all instruments in terms of the past values of the variables as well as the past values of the first differences of the variables. Okay. Now, let me quickly look at how to get these estimates in terms of the data. So we can use the same data file, it's data we have used at the beginning. So please open the data file again. It is visible.
Yes, sir.
Yes, sir.
So in dynamic panel, we have discussed 3 models. One, Anderson and Xiao. It is basically instrumental variable estimation method. By considering the first difference. Okay. Now in Stata, when you want to estimate a model by using instrumental variable, the command is ivreg. Okay. ivreg is the command for regression with instrumental variable. When it is used in panel, you can write xtivreg. So xtivreg, suppose we want to estimate the same model where GDP growth is used as a dependent variable. And labor productivity, log of output per worker as a regressor. Okay. So after specifying the dependent and independent variable, you have to specify the instrument to be used in this model. How to specify? After specifying the dependent independent variable, within bracket, first bracket, we are using lag dependent variable. Okay. So what is the dependent variable here? GDP growth. So L dot GDP growth. L dot GDP growth means it indicates YT minus 1. So what is the instrument we are using? YT minus 2. Just remember the model in Anderson-Xiao. So in place of the regressors YT minus 1, you are using the instrument YT minus 2. So L dot GDP growth is equal to L2 dot GDP growth. Bracket close. Okay. And Anderson-Xiao used the first difference model. So to specify the first difference, you have to write FD. So what is the command? xtivreg GDP growth. This is YT. This is independent variable, labor productivity. So this is XT, XIT. This is YIT. This is XIT. Within bracket, we have written the instrument. What is the instrument? YIT minus 2 is used as an instrument for YIT minus 1. And your model used the first difference. Okay. Have you written? Now execute this command. Have you got this result?
Yes, sir.
Now look at the output window. All things remain the same as for the fixed effect. Here we are using instrumental variable in place of applying OLS. What is the instrument? So, which is instrumented? We have instrumented this variable, GDP growth, L dot GDP growth, because GDP growth is used as a dependent variable here. What are the instruments? Instrument is L dot GDP growth along with the labor productivity per worker. So we assume here labor productivity per worker is purely exogenous variable. So if labor productivity is also treated as endogenous, so you can take the past values of labor productivity as the instrument as well. So we are considering outside variable only for GDP growth. Outside variables means the variable we are not using in the model. What is that variable? Variable is YT minus 2. So we have taken YT minus 2 in place of YT minus 1 along with XT under the assumption that XT is exogenous purely. Okay. So on the basis of that, you have got this result. So to eliminate fixed effect, you have used here the first difference. You can also use the within estimation model as well in the framework of Anderson and Xiao. So in that case, you have to write here FE, fixed effect. Okay. If you want to estimate the same model, by using Arellano-Bond, two-step GMM, you have to write the command in this way. The command is long, that's why I have copied it from other sources. So I have to change it according to our need. So the command for Arellano-Bond is XT-A-Bond. XT-A-Bond is the command. This part, XT-A-Bond. Then you have to write the dependent variable. What is the dependent variable? GDP growth. Then we have to write the regressors. What is the regressor? Log of output per worker. We are using AR1 model. So you have to write after comma lags 1. This is a two-step method. We need to adjust the heteroscedasticity. For that purpose, we have to written VCE robust. No constant. No constant means we are ignoring the intercept term. So what is the command? Just look at xt bond GDP growth space L of within bracket 0/1 dot log of output per worker. That means we are considering log of output per worker for the current period as well as for the past period as the explanatory variable. We have incorporated lag 1 in the dependent variable. দেখতে পাচ্ছ এটা লিখেছো? এটা দেখা যাচ্ছে কমেন্টটা?
Yes, sir.
Yes, sir.
লেখা হয়েছে? Then execute. So when you have written xt a bond, that means you are using Arellano bond model, and Arellano bond model indicates you are using all possible instruments in terms of the past values of the variable. Okay. So according to this method, your estimated result, estimated value for phi1, that is phi1 hat, is 0.1783, which is statistically insignificant. What you have got in the earlier model, coefficient for phi1, estimated value for phi1 minus 0.6786. It was also insignificant. In first difference, the value was minus 0.091. It was also insignificant. That means the AR1 coefficient is insignificant everywhere. But the coefficient for labor productivity is highly significant in all cases.
স্যার কমান্ডটা আরেকবার দেখাবেন?
বলছি কমেন্টটা হচ্ছে এইটা xt abond. xt abondটা হচ্ছে কমান্ড, তারপর লিখবে ডিপেন্ডেন্ট ভেরিয়েবল, তারপর ইন্ডিপেন্ডেন্ট ভেরিয়েবল। এবার ইন্ডিপেন্ডেন্ট ভেরিয়েবলটা হচ্ছে আবার কি? এইটা হচ্ছে আমার ইন্ডিপেন্ডেন্ট ভেরিয়েবল এল আন্ডারস্কোর আউটপুট পার ওয়ার্কার। তার আগে আমি লিখেছি এল উইদিন ব্র্যাকেট 0/1 ডট। আমরা তো এল ডট লিখি পাস্ট ভ্যালুকে বোঝাতে গিয়ে। এবার এল 0/1 মানে কি? আমি কারেন্ট ভ্যালু নিচ্ছি অ্যাজ ওয়েল অ্যাজ 1 পিরিয়ড ল্যাগ ভ্যালু নিচ্ছি, দুটোই নিচ্ছি। তুমি এস্টিমেটেড রেজাল্টটা দেখো তাহলে বুঝতে পারবে। লগ অফ আউটপুট পার ওয়ার্কার, তার এগেনস্টে দুটো কোএফিসিয়েন্ট রয়েছে। দিস ইজ ফর দ্য কারেন্ট ইয়ার ভ্যালু, this is for the past year value. If you want to ignore the past year value, you just write here data, then execute the model estimation.
স্যার আমাকে বারবার দেখাচ্ছে নন কনস্ট্যান্ট ইনভ্যালিড।
নন কনস্ট্যান্ট আর নো কনস্ট্যান্ট লেখো। নন
ও
কনস্ট্যান্ট
স্যার সরি, ওটা আমি ভুল দেখেছি।
নো কনস্ট্যান্ট লিখতে হবে।
হ্যাঁ স্যার এসছে।
If you want to estimate the same model by applying the system GMM, command is xt dpd sys, xt dpd sys. DPD means dynamic panel data system. xt dpd sys. Execute it. So this is the result you have got by using system GMM method. Now by comparing all the results, you have to choose the best one.